Okay, thank you for joining us today. This is a webinar from IAC Acoustics. Today, we're going to talk about a new product that we've developed and just recently released. This is IAC Acoustics Macrodyne Hardliner VRT room. So we're going to go over some of the details of the room, the flexibility that it offers for testing capabilities in one space. My name is Andrew Polte. I'm the NVH and Test Facility Sales Manager at IAC Acoustics. I have more than 13 years of experience doing NVH, or noise and vibration harshness testing, in automotive at Honda, working at the transmission manufacturing plant doing powertrain testing and also full vehicle. And also I have some experience doing NVH testing on heavy truck and construction vehicles with the commercial vehicle group. I have a Bachelor of Science in Mechanical Engineering from Ohio State and a Master of Engineering in Acoustics at Penn State. IAC Acoustics is part of the Catalyst Acoustics Group company. So the Catalyst Acoustics Group is a parent company that owns several other noise control companies, including IAC Acoustics. So combined, we have the largest product line of noise control solutions than anyone else in the world, and so we're able to provide full packages and turnkey systems for small enclosures, large enclosures, testing facilities on the industrial side, and in-plant noise solutions. Think of having to quiet down an air compressor that might be too loud around an operator's or worker's space. On the architectural side, also, we provide a lot of aesthetically pleasing solutions for studios, recording studios, radio centers, architectural studios, and lots of other types of performance theaters and open spaces. And also on the industrial side, we offer outdoor barrier wall systems, testing facilities, which is what my specialty is, and as I mentioned before, in-plant noise control. So for anything that's making a lot of noise that needs to be enclosed, dyno test facilities for powertrain with exhaust systems and HVAC silencers. And so we offer a very wide range of products. Our director, Thomas Hines, has been working in the industry for over 22 years now. The industrial sales manager, Ted Marquis, also has over 2 decades of experience focusing on in-plant noise control. And then Darren Riley is our HVAC product sales manager with a couple of decades of experience as well. And he focuses on HVAC systems, so silencers and louvers for HVAC and ventilation systems. And Ryan Wheeler is our industrial commercial sales manager. He focuses on barrier wall systems, typically outdoors. So before we get into the Macrodyne Hardliner VRT room, there's a couple different perspectives that we take when it comes to needing a high precision measurement space for acoustic testing and microphone and vibration measurements. Anechoic spaces, or the side on your left, typically absorb sound. If you have a noise source inside this space, sound gets absorbed by the surfaces, usually the walls and the ceiling. Sometimes the floor has absorptive treatment as well. So those are considered anechoic, where the sound does not reflect. And then the opposite of that on the right side is a reflective or a reverberant room or reverberant space, where the idea is to have as much sound reflection as possible, so that way, no matter where you are inside that room, you have about the same amount of sound pressure level at all frequencies in an ideal reverberation room. And those kind of systems are really good for measuring things like sound power, not necessarily with a direction in mind, but just being able to estimate sound power with 1 or 2 microphones. Those spaces are very good for that type of application. Another component to the VRT rooms is reverberation time. Reverberation time essentially defines how dead or live space may be. There's a wide variety of reverberation times that are just kind of inherent to certain spaces. An office environment, for example, may have a kind of a mid-level reverberation time, so there's some echo in there, but it's not completely dead either. Vehicles have a low reverb time as well because they're small spaces and there's a lot of absorptive materials and components inside a vehicle. Gymnasiums you can think of as very live spaces, so there's a lot of hard surfaces. The space is very large, so the reverberation time is going to be very high. And then homes, restaurants, and movie theaters, there's lots of different spaces with a wide range of times on them. What a reverberation time is defined as the time that it takes for sound inside of a room to reduce by 60 decibels. So you could imagine a speaker with a large speaker that's playing a high volume of 80 decibels or 90 decibels. And then you turn that speaker off. The time that it takes the sound to change from 80 decibels down to 20 decibels, that is the reverberation time. And those times vary quite a bit. So for example, in a gym with a highly reverberant space and a lot of hard surfaces, that reverberation time might be 2 seconds or more. Those are considered live spaces, whereas in a vehicle or in an NVH chamber, those times can be 0.1, 0.2 seconds. And so the sound drops off very, very quickly in those spaces, and those may be considered to be a dead space. So there's some equations on here and some math to define what is the cutoff frequency of these reverberation rooms in reverberant spaces. The bottom line really is that the cutoff frequency is defined by the volume of the room. So the larger the volume of the room, the lower cutoff frequency you can get. And what the cutoff frequency is the lowest frequency that you can accurately measure in a given space. So you can imagine if you need a 50 hertz cutoff frequency, for example, that is typically a very low frequency, and you would need a very large room and lots of treatment on the walls to be able to achieve that. One of the more common frequency cutoffs in automotive is around 250 hertz, and then so obviously that would require not as much acoustic treatment, and you can have a smaller space to be able to do your testing. Diffusion is another big key component to these highly precise measurement spaces. So in the photo here, you can see there's four square blocks with all these little squares within the wooden square blocks. These are diffuser panels, and the purpose of a diffuser panel is to break up the room modes inside of a room. So you can imagine the sound source in the middle of this room producing a sound. When it bounces off of a reflective surface, that sound wave can translate back and forth within the room and create these booming sounds. It's really prominent, especially at low frequencies. So the purpose of a diffuser panel is to be able to break those room modes up and have a nice even frequency response inside the room, no matter where you measure in that room. IAC's VRT rooms are designed for a lot of different types of testing environments. The VRT stands for variable reverberation time. So if you do need to simulate how a product may perform under different acoustic conditions inside a vehicle or inside an office or an indoor swimming pool or gymnasium space, the purpose of a VRT room is to be able to set up measurement systems in those type of spaces in one room. So we have 3 different types of panels that we use for the Macrodyne variable reverb time rooms. The first type is the diffuser panel that I mentioned before, and you can see it in the photo on the left, where the sound is being broken up into and scattered about different areas within the room. The second type of panel is more of a reflective panel. So those are the white tiles that you can see. Those are very hard, very smooth surfaces designed to reflect sound with minimal absorption and loss of the sound energy from the wave passing through. On the right picture, there is a couple of beige panels. Those are absorbers. So those do pretty much exactly the opposite of what the reflection panels do. those will absorb the noise. That's part of the anechoic side of the room. These panels are removable. They can be configured to a pretty large number of spaces in a lot of different environments, so that the user can tune the configurations to specific reverberation times at specific frequencies. You're able to have multiple settings in one room. If you need to simulate a very dead space of around 0.2 seconds, and you also need to simulate a reverberation time of 2 seconds where you have a very reflective surface, rather than having to purchase and have the space for several different types of rooms, you can utilize one system in one room to measure a lot of configurations. So it saves you a lot of space, and it saves you a lot of time and cost in your testing environment. These rooms are designed to meet specific criteria set by ETSI, ISO, and ASTM. There are several different standards for each. ETSI is a really common one. There's a very specific ETSI standard that I can get into a little later that actually defines the range of reverberation times that are needed to test small devices like communication devices. Think of your smartphone or headphones for anybody using a computer or listening or making calls. The manufacturers of these products really need to understand how their devices perform in a variety of spaces. IAC's Macrodyne Hardliner VRT rooms, as I mentioned before, they really depend on the size of the room to determine what is the lowest frequency that you're able to measure. So the table on the left just shows a few examples of that. If, for example, you need to measure down to a 125 hertz octave band or a 100 hertz third octave band, then you need a room that's roughly 7,000 cubic feet or 200 cubic meters. Now, that's a pretty good size room. But if you need that low frequency accuracy, then that's the kind of size that you're looking at. All the way up to 250 hertz is more commonly used for automotive applications. You can imagine a vehicle interior doesn't get too large, so higher frequency cutoffs are usually acceptable for developing noise package materials in automotive and in transportation equipment. 200 hertz 1/3 octave band requires a 24 or 2,500 cubic foot room, or about 70 meters cubed. So the big advantage of the IAC Hardliner VRT room is that it is a very modular enclosure. IAC manufactures all of the components for the steel details, the panels themselves, the doors, vibration isolation systems, flooring. We can package that into one solution that meets your needs. And we do have a few standard sizes available, but these are made to order, and they're very customizable solutions too. So depending on the space you have available, what your performance requirements are, we can tailor the individual panels and doors and everything to give you a package that meets your specific application. They have a very high level of sound transmission loss. All of our panels and ceiling panels and doors are acoustically rated. They have been tested for specific performance requirements, and so we do guarantee that performance. I want to talk a little bit more about IAC's Noise Lock brand of doors. So the Noise Lock doors have a very specific acoustic performance rating called STC. That stands for Sound Transmission Class. And what that is a measurement of how well the sound is blocked by the door. So you can imagine an STC 43 door is going to be kind of our standard level performance, and we're able to go all the way up to an STC 64 door. And essentially what that means is that the higher the number, the more sound that is able to be reflected and kept out of your enclosure. There's a couple of photos here. The one on the left is for a noise lock door with a full glass window, and that is sitting next to inside of a control room, which is mounted next. It's kind of hard to see on the very left there, but you can kind of see some wedges attached to the hemianechoic test cell. there are a lot of manufacturers of communication devices that, as I mentioned before, they're very interested in how their devices perform. And one of the most common measurements metrics that are used is something called speech intelligibility. And essentially what that means is it's a measurement of how well someone is able to be understood through these communication devices. So you can imagine speech intelligibility in a very live room with a very high reverberation time. There's going to be a lot of echo, a lot of background noise, and so it might be hard to listen or to hear somebody, to understand them in a room that's going to be highly reverberant. Similarly, in a very dead space, you may be able to hear somebody a little bit better close up, but possibly far away, it might be harder to understand them. So there's kind of a sweet spot depending on what kind of environment you're in. What's the optimal solution for speech intelligibility? And customers and manufacturers both need to be able to understand how well their devices are performing in a pretty wide variety of these spaces. There is a specific standard on the left side. You can see there's a few standards for ISO for reverberation and hemianechoic room measurement, and then the one on the bottom here, that's the real critical one for these VRT rooms, is ETSI. ETSI EG 202396 defines the measurement method and the space, the performance requirements of the space for the measurement methods to be able to accurately measure speech intelligibility. The space requirements are given, certain sizes is spec'd out, and then there's a range of acceptable reverberation times for the room from 0.2 to 0.7 seconds. Now IAC can perform, can manufacture VRT rooms that meet that performance range criteria, and we can actually go slightly below it down to about 0.15 seconds. And then we can manufacture rooms that are large enough, that are highly reverberant. We can go all the way up to 2 seconds or even more, depending on your application specifically. So we're able to cover that range of ETSI reverberation time specifications, plus or minus on top of that, if you have some acoustic requirements that go beyond those basic that basic range. That's about it. That's all I have today for the VRT rooms. Feel free to visit our website at iacacoustics.com. There's a section there under test facilities. There we have a lot of information, some photos and brochures and case studies of test chambers we've done in the past for anechoic rooms, automotive test chambers, and under reverberation rooms, you'll see a separate section for the Macrodyne VRT rooms. Thank you very much for attending the webinar today. Feel free to reach out to me at apolte@iacacoustics.com, and my phone number is there as well. We do have a few minutes left. If there's any questions, feel free to put them in the chat window or shoot me an email if you think of something after this. I'll wait here for a minute or two to see if any questions come up. Okay, somebody is asking me, what is the difference between the different panels that I showed earlier? Yeah, okay. So let me go back to the pictures here. Okay, so the panels in the upper right corner, there's two different types of panels here. It's hard to see which one's which in the photo, but if you look at the white panels on the left, those are reflective panels. So you can imagine a painted concrete surface, for example, is going to be very highly reflective. Sound is just going to bounce right off of there. And that's what these white tiles are designed to do, is to reflect sound. On the right, the beige panels, they're absorber panels, and their whole purpose is to be able to absorb sound, so that way when a wave hits it, a sound wave hits it, that sound gets absorbed and does not get reflected back into the space. So there's a variety of reasons why you want to have reflective panels versus anechoic panels or these absorbing panels. If you need to meet a specific standard, and these are definitely not all inclusive, ISO 3741, this top standard here, for example, that's designed for a very reverberant space to measure sound power. So it's going to be designed for a very reflective surfaces on the walls, the ceiling, and the floor. Like I said before, in an ideal reverberant environment, you'd have perfect reverberation, and no matter where you are inside that room, if you stuck a microphone anywhere in the room, you'd be able to measure the same sound pressure level at all frequencies anywhere in the room. That would be in a perfectly reverberant space. Obviously, no space is going to be perfectly reverberant, but these panels and the diffusers that I mentioned earlier too are designed to help try to smooth out that frequency curve as much as possible. Okay, I don't see any more questions on here. As I said before, feel free to reach out to me, Polte at iacacoustics.com, and I'll be happy to talk to you if you have any specific questions, or if you're not sure where to start. We can help work through any applications you might have as well. If you just give me a space, some size requirements, and the frequency, lowest frequency you need to measure, so that's a really good starting point, and we can kind of build from there and develop a solution that might work for you. Once again, thank you for everyone's time. I appreciate it, and have a great day.